Yeah, thanks, Meiring. We're going to try to pass this microphone back and forth, but our mission is real simple, and I think that was really well put, is that we're trying to help everybody. And we have a very specific mission and a very specific solution that can help us accomplish that. It's this amazing natural mineral called zeolite. So you're gonna learn a lot about zeolite today. Show of hands, who's heard of zeolite before? Oh, it's amazing. Usually it's zero, so that's congratulations to all of you. But we're really proud that we have a domestic, made in the USA, natural, organic, equitable solution that I think is going to be really exciting. And for those of you that came by our booth yesterday and got to see our video, you get to see it again. But we're going to talk about the amazing results that Mukilteo is seeing here in just a second. A little bit about our company. We're more of a community of companies than a single entity, but we believe that research and science needs to power everything that we do, especially in a landscape like this, where we're talking about stormwater and stormwater solutions. So we're very proud of our partnerships with University of Washington system. So UW Seattle, UW Tacoma, Washington State University. I'm sure there's many of you here that represent multiple of these places. And so we have these companies sort of aligned with these parts of our mission. And we'll talk about this as we get through the presentation today. So zeolite, everybody raise their hands, so maybe I can skip this. I'm not going to show this particular video, but there is a link on our website and in this presentation that you'll all get that will take you to a really short animated video about what zeolite is, where it comes from. So basically, we're blessed that Mother Nature delivered this resource to us over the last few 100 million years. And what we're able to harvest is this amazing natural honeycomb-shaped mineral that has amazing superpowers, as I like to put it. And we're going to see in action some of these superpowers here in a second, where it's highly absorptive and also can do things to attack and render harmless toxins in the local environment that it's supplied into. All right.
Thank you, Neil. All right. Now, why you came? Who has a decant facility in the room? All right. Nice. So the City of Mukilteo has a decant facility. It's fairly new, opened in 2021. It was about $1.6 million, mainly paid through ecology grant. We have 4 bays, so a fairly large area. So 3 of the bays are true decant facilities where we can siphon the water off. And then the 4th one on the far right side of the picture on the left is the dry bay. So when I started with the program, I inherited a program that I think we picked up from Shoreline, where we are cleaning and CCTVing all 75 miles of our pipe. So we are pulling out quite a bit of sediment out there because it's never been done, right? So those pipes have been in the ground for 70 years or more, and so we're pulling out all the material out of it. Now, so we bring it into the decant facility, and what I found was that the crew was getting backed up because it takes so long for this material to decant. One of the main reasons is because of the glacier till we have. It's very fine sediment, so it stays suspended in the water column forever. And it just doesn't want to settle out. And then whatever settles out and goes through, then that we miss through our decant facility that has 4 different weir structures as it moves through to the sanitary lines. A lot of that fine sediment still makes it into the sanitary line that then gets to a grinder pump, and our local water and wastewater district who's receiving the decant material does not like that because we burn their pumps out. Right? So I was trying to find a way of how we can do this more efficient. So my first option was build another decant facility so I have more space. That's $1.6 million, not a good idea. And then I met Sarah, and she's kept pushing this thing with me. So anyway, we met, and they came out, they brought up a super sack for us, and we put it down, and I think this is the way to go. Because this is a process, right? Decant facilities is a process. So you have to always look at how you can improve your process the best. So how can we improve this process to make it faster? If we just do it the way we're doing it and the way it was designed, it can take between 7 and 14 days a little. Not enough. It's actually more like 3-4 weeks for that decant to go down, and before we can pull out the sludge to transport it to Cadman, where we take our material. can't take slosh because then we have an IDDE all the way on the way there. So what we decided to do, and because of the CCTV program, that's an ecology program, we have to take samples. I can't mix it with my street sweeping material because then it's going to mess up my pollutant load that I'm removing that I have to report to ecology. So next slide. This is what it looks like. It's a sloppy milkshake that goes in, it drains down, and then you have this very fine material in there. So most of you probably mix it in with your street sweeping material or other material to get it to a situation where you can transport it or get it out of the bay. For this project, I can't do that. So what we decided to do is to add the zeolite to it, so we can pull out the water.
All right, so this is where we're
through pulling out the water, what we do, the zeolite also captures most of the metals, and the metals are then combined with the zeolite material. So not only does it pull in the metals then don't go to the wastewater treatment plant. So it's actually removing a lot of pollutants right here, instead of having to send those pollutants to the wastewater treatment plant, where hopefully it gets removed before it goes into the Puget Sound. Okay. We have a short video, we'll see what it was. Monday, April 28th, City of Mukilteo. We are going to be adding our zeolite to the bay number 2. This is where the decant material for the last 2 weeks has been going. The material, as you can see, the line at the top, that was from Friday, that was the height of the water line. Water's been draining down over the weekend. What's left now is the muck. It's a very fine material and stays like this for weeks. So this is why we are using the decant or the zeolite in the decant facilities to speed up the process. The zeolite will be mixed with the muck as the whole milkshake, thicken it, so we can then manage it and work it and get it all loaded on the truck this afternoon to be disposed of. Here comes the zeolite. We have it on the front of the fork. So in this instance, they're going to open the bag at the bottom, and then we're going to work it into the front first. The reason why we're working it into the front is so we can solidify the muck in the front, and we'll put the bucket on, and then the bucket will work it back, so we don't track the mud back out onto the parking lot area that there has to be cleaned up with the sweeper. So we're going to do a little bit differently today by working the zeolite into the front, then use the bucket to sweep it back. We've also, there you go, there goes the zeolite. It's a very fine material. And we've also modified this bay. You'll see there's an asphalt berm in front of it. So that berm is about 1 foot high, so you can get more capacity. Because before we did this, the previous years, there was no berm there, so really you couldn't even get that much material in there. One super sack that was placed on the material, so we put it on about 2/3 of the bay. Yeah, then we come in and we just mix it up. So you take the dozer and you just mix it up, get that all mixed with the powder. This takes about 30 minutes. So yeah, so it's about a 30-minute process versus a 3-week process. So we can get the sludge picked up quicker. We're removing actually a lot of whatever is suspended in the water column, any of the pollutants, we're capturing it, and it's captures there forever. Neil will talk more about the process of zeolite, but it doesn't release the metals or the pollutants. It captures it and it holds it then forever. And then that material we then take to Cadman, and they put it through their burner and mix it with their asphalt mix. So that's what that is for. So The reason why we thought to bring this to the community is because it's a dramatic change for the City of Mukilteo in our process. So it used to take 7 days to 30 days to move the material through the decant facility. Now I can fill up my decant bay and I can apply my super sack. Well, in that case, that was a lot, right? So I could 3 sacks in that one. And the super sacks are about $250 a sack. So we're still working on what the best way to do this, the most efficient way, the most cost effective way. So maybe we should do less at a time, less material in the decant facility before we start applying the zeolite. We've been looking at ways to apply the zeolite. Should we have, right now we're just putting it on the forklift and shaking it around. Should we have a system where we have a spreader, some kind of commercial or agricultural spreader that we have in the bay that we can just turn on and it spreads it like you would do with the flocculant in a vault system. So we're still working through ideas. And then how to store the zeolite is our next question. So the zeolite has to be stored indoors because it pulls in atmospheric moisture as well. You don't want to have a super sack that you then half of it's gone because it's full of moisture already. So storage is something to consider when you use this. We luckily have a new decant facility, and so we also have inside storage that we are using now. And if this works, then I'll maybe rent some storage from the industrial facility next door to us, so I can always store it there and just pull it out of there. But that's something you'll have to think about, is where you store it. So this costs us less money in the long run because we can move through. There's no staff waiting for the decant facility to clean out. So our process is much smoother, much faster. I can do mile after mile after mile of pipe cleaning without holding back. So once they get going, they can just keep going. I don't have to wait a week or two when my decant facility is full for it to drain down. I'm removing more pollutants, and time is money. So that is why I really like the system at the moment. Also don't have to build a new facility. I can use my existing facility. I'm just improving the process. So from a money perspective, as I said, because we don't have to build another $1.6 million facility, I can use this material to shorten my time. I am helping with the water treatment, so it's actually costing the wastewater treatment facility less money because it's less treatment they have to do. My disposal cost could be cheaper. I'm putting the zeolite into my material, which adds to my tonnage that I'm paying for disposing. But we are looking at maybe can we be paid for this material, because as Neil will explain, that because the zeolite is in this soil medium, this might be a good medium to go back into a farmland or into other remediated soil. So maybe we can actually sell this product that we're creating here, because with the zeolite in the soil medium, it's actually beneficial for other applications in the real world. So maybe instead of it being a cost for us to throw away, we can actually sell it to somebody that we can take it to, or they can pick it up. And then human capacity. We need less people to manage all this material in the facility, and our staff time is much more improved because we can keep moving through our projects. So and this is important, something important to think about for those of you that put your hands up that you already have a decant facility, because you're now going to have to manage your street sweeping material. Maybe you're going to have an increased amount of street sweeping material. For those of you who don't have decant facilities, you're going to have to think about where you're going to take your materials, because the materials are going to have to go somewhere. Are you going to have to drive 60 miles to a decant facility? Or can you find somewhere closer? And maybe somewhere closer, if they use this material, they can actually handle more volume, more traffic through their decant facility. And then this whole presentation also for me ties into another grant we received from the Department of Ecology through the 6PP3 program, where we are looking with all the partners in Western Washington to increase decant facility capacity in Western Washington. So this will be a very interesting tie-in into that whole process.
I want to park here for a second. I actually sat in the presentation previous to this to make sure we were ready to go. And it's amazing how they were working on pond and water management systems. And we're talking about decant facilities, but there's a very strong common thread, which was they're implementing solutions to save them millions of dollars in avoiding the expansion or build of new ponds. And the concept is very similar here. I mean, what the city of Mukilteo is doing is kind of cutting edge, but it's an extremely intelligent approach to maximizing the capacity of their facility, which actually can help everybody else too, because if you don't have a facility of your own and you need to truck it to the nearest one and they're already at or over capacity, you can now partner differently with your friends across the city and county lines to come up with solutions to use existing footprints and existing infrastructure to actually get more out of it. And so we can build less decant facilities. We can reimagine new ones to avoid drains and catch basins and all the work that goes into cleaning those and maintaining those over time. This is a very cost-effective solution that is a really interesting alternative to consider when you're thinking about not just the function of decant, but the cost over time, which is just getting more and more and more, especially as land gets more and more expensive. One other thing that we're doing too, and we're going to be partnering with Mukilteo on a bioretention cell, is that in terms of what zeolite can do, this presentation is mostly talking about our advantages in helping decant process become better, smarter, cheaper. We're going to be using some of these lessons learned and some of this technology in helping to optimize bioretention construction in the city of Mukilteo. And so I mentioned earlier that zeolite has a lot of superpowers, and helping with decant is certainly one of them. But if you've been by our booth, and if you haven't, I please encourage you to come by for a few minutes. We've built, using zeolite as the replacement for cement, the world's lowest carbon footprint concrete pavers. And that approach actually can pay forward into ready mix and other concrete type of solutions. And so this zeolite material is actually quite flexible in terms of what it can do for us in our environment, reducing toxin load, carbon footprint load, and just a more environmentally friendly approach to a lot of different solutions that all of you here, I think, are looking for. And since we probably have about 3 minutes left, I'm going to park on this page. Here are our contact details. Mine, feel free to call or email anytime. I'm sure Meiring would say the same thing. And with that, we should probably turn it over to the audience.
Yeah, any questions? I'm going to come to you because otherwise the folks online can't hear the question. Any questions? Everybody at once. No, I've not. So yeah, there's also corn husks and sawdust and other things you can use. Right now, this is just the easiest thing for me because it's also capturing the pollutants. So for my CVs, if I just were cleaning my CVs and things like that, I would have just mixed it in with my street sweeper because we're fortunate enough to have a street sweeping program. So I have stuff to mix it with. But for the pipe cleaning program, because I have to measure the pollutants I remove, I have to be careful also other things I mix in, but no, I've not used any other material. So we tested. So my main thing in phase 1 was lead. I had a lot of lead in the first one. I have not had a lot of lead in my second phase so far. I don't know if it's just the different area that I'm cleaning right now, because it's not in direct path of the flood problem. So Mukilteo is Plainfield Airport. So I think a lot of the lead in the first phase was falling out in that area. So that's what I've not found. What we are going to be testing for is, because I want to be careful of this, is that I don't create a hazard, right? Because if zeolite is capturing all the pollutants, am I now going to have a lot of pollutants per pound that's going to make it trigger something else? We haven't found that yet. So we've been testing our loads, but it's actually lower than it was in phase 1. So I don't know why that is. Maybe Neil will know why. But yeah, so I mean, we haven't tested any of this stuff. So these are just ideas, right? We always throw ideas out. That's where the world starts with ideas. Because I think me and Neil were talking about it because we always just think of the easy way, right? So dispose of it, put it on the sidewalk, get rid of it. But what if we can rather turn something that we throw away, something we can use? Might not be agricultural, and it might not just be for road waste, right? decant facilities have different materials coming from different places. So it will depend on what's in the material, and a lot of places still put poop on on their fields. So I don't know if Neil wants to expand on that. We have 1 minute.
Yeah, I got the thing.
Okay.
Yeah, so you can run around and grab some more questions. So really good questions. I missed one because I think we're trying to figure out why the slide from sharing instead of the desktop, but just real quick. So another superpower of our zeolite, which is unique across the family of zeolites, is that when it's hydrated, it will perform a cation exchange with things around it. And so our zeolite becomes a very heavy, negatively charged magnet effectively. And so as all of you probably know, lots of the bad things in our environment have a positive charge. And so when that cation exchange happens, you basically make the toxins bio-unavailable. And so they're rendered inert. And so whether we put it into the food supply is a fair question. But I think, first step is Mukilteo is paying for the privilege of sending their sludge to Cadman, and then Cadman is accepting that privilege and then repacking and selling that material, which they've produced at a cost, to customers. And so you can start to think about all the opportunities of taking the residuals, whether it's incinerated or potentially to a landfill, and then repurposing that either as a cost reduction, probably should be the first conversation, or even a profit center. And so we were talking in Tacoma recently, they had a sustainability event, and there's a city function, I forget the name of Taro. There's a part of the city that's effectively repurposing wastewater treated sludge as fertilizer. And so they've figured out a way to repurpose what would normally be only a cost center into a way to make some money for the city and take advantage of what they're producing anyway. And so there's all sorts of possibilities, and whether this residual is used in landfill, backfill, asphalt, concrete, there's all sorts of uses that are very safe, even if it's bound to toxins that we think are very dangerous, even though they might be bio-unavailable. There's lots of options for this.
All right. Well, yeah, contact us if you want more information. Thank you very much.